Chapter 5.2, exercises 19 through 24. This section 5.2 has to do with verifying trigonometric identities, and I'm going to work out the odd number problems 19, 21, and 23. Problem 19, fireworks. If a rocket is launched from ground level, the maximum height that reaches is given by h equals v squared sine squared theta over 2g, where theta is the angle between the ground and the initial path of the rocket. V is the rocket's initial speed, and g is the acceleration due to gravity, 9.8 meters per second squared. And then we have part A and part B. Part A being verify that v squared sine squared theta over 2g equals v squared tangent squared theta over 2g secant squared theta. And if you look at this formula, this equation, you have v squared over 2g. Those are common between these two sides of the equation. And so what we're going to do is verify everything except v squared over 2g. In this case, that's going to be sine squared theta is equal to tangent squared theta over secant squared theta. And what I did yesterday when I tried to work this out is I used the Pythagorean identity with the secant squared theta in the denominator. But I think it works out a lot easier if we understand and we go back to the reciprocal identity that secant theta is equal to 1 over cosine theta. Okay, so now I'm going to go back and replace. And I'm going to just leave sine squared theta by itself on the left. And I'm going to bring down tangent squared theta. And we're going to rewrite secant squared theta as 1 over cosine squared theta. Now, tangent squared theta, I'm going to fix that up too, because tangent theta, we use the quotient identity, is equal to sine theta over cosine theta. And so using our quotient identity, I'm going to replace tangent squared theta with sine squared theta over cosine squared theta. And then I'm going to bring down what I had left, which is 1 over cosine squared theta. And dividing by a fraction is the same as multiplying by a reciprocal, so I'm going to bring down sine squared theta over cosine squared theta. And then instead of dividing by 1 over cosine squared theta, I'm going to multiply by the reciprocal of 1 over cosine squared theta, which is cosine squared theta over 1. Now, what do we see happens here? We got in the numerator cosine squared theta, denominator cosine squared theta, they cancel each other. And what do we have left? We have sine squared theta. So, in this case, we have the left side, sine squared theta, equaling what we simplified to on the right side, sine squared theta. And so we've demonstrated and verified that this left side of this identity equals the right side of the identity. Check. Next, suppose the second rocket is fired at an angle of 80 degrees from the ground with an initial speed of 110 meters per second. Find the maximum height of the rocket. And so we're going to take this for part B, h, and that's going to be equal to v squared sine squared theta over 2g. In this case, h is going to be equal to, we'll just fill in the blanks, v, we have initial speed of 110 meters per second. And then we have our sine of 80 degrees, so we'll put sine of 80 degrees, and we're going to square that, and then it's going to be over 2g, and g being 9.8 meters per second squared. And so we just need to go to our calculator. We'll need the calculator for this. I think it's the only time in this entire section I'm going to be using, oops, that's not it. Only time in this entire section I'm going to be using calculator. So we have 110 squared times, I'm going to put sine of 80 degrees. Now I've already checked my calculator to make sure that we are in degrees and not in another thing, which would be radians. So you have sine of 80 degrees. Come outside of here, and we're going to square this, and we're dividing by 2 times our gravity, which is acceleration due to force gravity, 9.8. So we get about 598.7 meters. So we'll go here, 598.7 meters. So that's problem 19. Let's go to next odd number problem, which is 21. We have sine squared theta, tangent squared theta equals tangent squared theta minus sine squared theta. What we're going to do in this one is work with the right side until it equals the left side of this identity. And what we're going to do is take this tangent theta, we're going to use this identity, tangent theta is equal to sine theta over cosine theta. And so replacing this, we have sine theta, sine squared theta over cosine squared theta. And I'm going to rewrite this sine squared theta as sine squared theta over 1. Now, why am I doing this? I'm doing this to kind of demonstrate that we're going to get a common denominator between these two fractions and sort of putting them in equal position. And so to get a common denominator, our common denominator between these two fractions is going to be cosine squared theta times 1. So cosine squared theta is what we're looking for as a common denominator. And so on the left side, we have sine squared theta over cosine squared theta. So we didn't have to do anything with this first fraction. Now this next fraction, we're going to take sine squared theta over 1 and multiply it to get a common denominator by cosine squared theta over cosine squared theta. Okay, so now what we have is a common denominator. And that common denominator we have is, I'm going to put this over our now common denominator of cosine squared theta. And in our numerator, we have sine squared theta minus sine squared theta cosine squared theta. Okay, so hope that's pretty understandable. And now we're going to factor out from the numerator sine squared theta minus sine squared theta cosine squared theta. We're going to factor out the common factor between those two, which is sine squared theta, and that's going to be times quantity 1 minus cosine squared theta. And that all over cosine squared theta. Now, if we take the first Pythagorean identity, sine squared theta plus cosine squared theta equals 1, if we subtract cosine squared theta from both sides of this identity, we get sine squared theta is equal to 1 minus cosine squared theta. So we can replace this 1 minus cosine squared theta with sine squared theta. So now we're going to come below and make a little more room here. We're going to have sine squared theta times sine squared theta over cosine squared theta. Well, sine squared theta over cosine squared theta equals tangent squared theta, right? Look at this first identity up here at the top. So we're equal to tangent squared theta, and then we have just sine squared theta, which is the same as the left side here, sine squared theta tangent, in a different order, of course, but because the commutative property of algebra. And so we have verified the right side now equals the original left side. Check. Next odd number problem, which is 23, we have 1 plus cosecant theta over secant theta equals cosine theta plus cotangent theta. And in this case, what we're going to do is work with the left side of this equation and get the left side of the equation equal to this right side, cosine theta plus cotangent theta. And what we're going to do is take this reciprocal identity that cosecant theta is equal to 1 over sine theta. And also in the denominator on the left side, that secant theta is equal to 1 over cosine theta. And so we're going to use those identities first on the left side. And so rewriting, and I'm just going to come down on the right side and just let that go down, just work on the left side. So now on the left side we have 1 plus, instead of cosecant theta, we write that as 1 over sine theta. And over, we have 1 over cosine theta. So we're talking about verifying, we're trying to simplify this left side. Well, in simplifying, a lot of times we expand out to make bigger first. And so what we have in the, working with this numerator here, 1 plus sine theta, we're going to rewrite this 1 on the left here as sine theta over sine theta. So we've just rewritten that 1 as sine theta over sine theta, and on the right side we're going to keep 1 over sine theta. Okay, and then in the denominator we're going to bring down this 1 over cosine theta. And now we're going to, in the numerator, we have sine theta plus 1 over our now common denominator in the numerator of sine theta. In the denominator, we have 1 over cosine theta. Okay, I hope you can see that. I'll just bring this up a little bit to make a little more room. There we go. So now what we're going to do is kind of go to the upper right just to make some room to work below. And we're going to take this sine theta plus 1 over sine theta divided by 1 over cosine theta and rewrite that as sine theta plus 1 over sine theta. And instead of dividing by 1 over cosine theta, we're going to multiply by its reciprocal, which is cosine theta over 1. Dividing by a fraction is the same as multiplying by its reciprocal. So that's all we've done. And then I've wrapped this numerator of sine squared by sine theta plus 1. I've wrapped that in parentheses. Okay. And so what we have now is we have this cosine theta over sine theta becomes cotangent theta. So I'm going to rewrite this cosine theta over sine theta as cotangent theta. So I have cotangent theta times, and I'm just going to write this out on the right here. I'm going to put cosine theta over sine theta equals cotangent theta. And then I'm going to bring down this sine theta plus 1. So you have sine theta plus 1. And so it's going ahead and working through like this, distributing the cotangent. So we have a cotangent theta times sine theta. So I'm just going to write this down here. Cotangent theta sine theta plus cotangent theta. And so already we're looking close to this original right side here that I'm circling in red. We already have that cotangent theta. But let's go ahead and take this cotangent theta and rewrite that as cosine theta over sine theta times sine theta. And we just bring down this plus cotangent theta. And then what do we know? This sine theta over sine theta cancel each other to equal 1. And then what we have left is cosine theta plus cotangent theta. So check. Our left side we've manipulated to equal our right side. They are now equal. So we have verified this identity. So good luck on your even number problems as a demonstration for learning, and thanks for viewing.